Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Eric Watkins about turfgrass mixes for salt-affected roadsides. Salt is commonly spread on roads in colder regions to help keep them clear of dangerous ice. However, salted roads can pose some environmental risks. Roadside turfgrasses can help alleviate some of these problems, but drought, heat, salt, ice, and more can mean a roadside is not always the happiest place for grass to grow. This episode, Dr. Watkins walks us through some of the harsh conditions roadside turfgrasses face, the pros and cons of several popular grasses, and how we can wisely mix them for resilient roadside spaces. We'll talk more about that in a minute, but before we dive in, we wanted to thank our sponsors, starting with Meter Group. Meter specializes in robust soil moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Listen to their new podcast, We Measure the World, to hear how innovative researchers leverage environmental data to make our world a better and more sustainable place at metergroup.com/fieldlabearth. Our second sponsor is Gasmet Technologies, the maker of the GT5000 Terra, the smallest portable FTIR multi-gas analyzer for greenhouse gas and environmental research. Measure carbon dioxide, carbon monoxide, methane, nitrous oxide, nitric oxide, nitrogen dioxide, ammonia, and water vapor in real time simultaneously from static or automated chambers. Visit www.gasmet.com, that's Gasmet spelled G-A-S-M-E-T, or email sales@gasmet.com for more information. I'm your host, Abby Morrison. Let's talk about science. Hi, everybody. Welcome to the show. Today we have Eric Watkins with us. Eric is from West Central Minnesota. He attended the University of Minnesota as an undergraduate and received a bachelor's in science and agriculture. He then went to Rutgers University, where he received a PhD in plant biology while doing research in the turfgrass breeding program. He started his current position in Minnesota in February of 2004, where he focuses on breeding low-input turfgrasses for cold climates. Hi, Eric. How are you doing today?
Great. Thanks for having me.
So glad to have you on the show. Just FYI to our listeners, I am battling a bit of a cold today, but we'll do the best we can. Sorry if the audio is a little off. But today we are talking about roadside turf grasses in areas that use ice in the winter. So to get us started, Eric, can you tell us a little bit of the history of de-icing salt and the rationale behind its use?
So in cold climates where we have a lot of snow and ice buildup on roads, of course, sodium chloride primarily as a de-icing salt is used to keep the roads safe during the winter. And this started maybe about a little less than 100 years ago as there were more and more highways being built, and it was obvious that there was a need to figure out a way to make them more safe during the winter. And of course, as the use of vehicles and automobiles expanded, there was more and more roads and more need for de-icing salts. So of course today there's just a lot of de-icing salt used throughout the world in cold climates. And of course there's a need for it because we need our roads to be safe during the winter. For anybody who's lived in the northern part of the United States for any length of time, for those of us in Minnesota for sure, understand the importance of making sure the roads are free of ice and snow during the winter.
Sure. So obviously there's a need to keep the roads clear, but I know in your paper you mentioned that there are some environmental concerns that can come with that process. Can you talk about that a little bit?
So sodium chloride, when used at great amounts, is going to cause some problems. One, and really the focus of our work, is that it is going to cause problems with vegetation. So it's going to damage the vegetation near the roadside. And when there's damaged vegetation, when vegetation dies along roadsides, there's going to be more exposed soil, which leads to more runoff. So that's one problem. Probably a greater concern, especially in the Twin Cities right now, and in similar climatic regions, is that as we have more and more use of road salts and greater concentrations of populations in these urban areas and need for road salts, we're starting to see quite a bit of road salts getting into water bodies in urban areas, and this is causing problems with the health of lakes and other water bodies in these climates.
Sure. So part of what your paper is about is kind of developing some roadside turfgrass mixes that can help alleviate some of those problems. So I'm going to throw in a bonus question, which is kind of what does a roadside mix aim to do to alleviate some of these problems?
So a good seed mix for roadsides is going to hold that soil in place. So we really want to make sure that any mix that we put on a roadside is going to prevent erosion of soil. We need in some cases there's aesthetic concerns, right? If you're in a city in front of a commercial district or something, or a residential district area, that there's a need to have roadsides that are aesthetically pleasing. Roadsides can also play an important role in reducing the amount of runoff from the roads that finds its way into our water bodies. So a good, thick, dense stand of turf is going to help with some of that as well. One of the reasons a lot of roadsides are mowed is to improve visibility. So that's where turfgrasses come in, they're well adapted to mowing. They can be, and while still doing all of these other things. Now, of course, the problem is that when you have, there's many stresses on a roadside. We've talked about the road salt problem, but roadsides also have other problems. There's quite a bit of heat stress, so these areas are quite often hotter than nearby areas. They don't get maintained very well, so they're not getting irrigated very often. They don't receive very much fertilizer. They don't receive any other turf management practices beyond mowing, and that creates some problems for just overall turf performance. So we need a roadside turfgrass seed mixture that, first of all, will be tolerant of those higher salt conditions. So that's usually our primary objective. But in addition, the roadside mix also needs to survive all of these other stresses that come throughout the year, and they come in different orders. You might have salt stress in the spring, and then followed by a drought, followed by and all happening in poor nutrient conditions, for instance. So you need a very resilient mixture of species, and one that is going to provide that cover that you really want along a roadside for a long period of time. You don't want to have to be reseeding these every year.
Sure. And so when are these typically reseeded? That was a question I had when looking through your paper. Is it just, like you said, you don't want it every year. So, what's the schedule on that?
So roadsides are initially seeded or sodded in some cases during road construction projects. So whether it's a replacement of the road or a new curb and gutter system, for instance. So there's a contractor that comes in and initially seeds that road. And one of the challenges we have is that this can take place at any time during the year, right? During the growing season. So you might have one roadside seeded in April and another in July and another in October. Well, we know that there are ideal times to seed these grasses, and in Minnesota that is typically August and September. But oftentimes these roadsides are getting seeded at non-optimum times, and there's another thing that we have to consider when designing a mix. If a roadside is going to get seeded at a non-optimum time, is that mix still going to do well for that site? When roadsides are damaged, sometimes they don't get reseeded at all, or they get reseeded possibly, in early summer, midsummer after a damaging winter.
Okay. And do you, a couple questions here. First of all, how many grasses are going into these mixes typically?
That's going to vary quite a bit based on location. Each state has their own recommendation, but usually it seems like most recommendations are somewhere between 4 and 6 different types of grass. There are 4 or 6 different species, and within that there might be multiple cultivars within each species. Now, if it's a sodded site, sometimes it's going to be fewer, more Kentucky bluegrass and less other species.
Sure. Okay, that's interesting. And then, how do you alter what mix you use if depending on when it's planted, or is it just kind of this is what we have for the region? How specialized is this?
Now, I'll use the case of Minnesota. So right now there are statewide mixtures for Minnesota. So there's a mixture for a given type of site. So there might be a mixture for, they may classify it as, residential sites. There'll be one mixture for the whole state, even though the state is quite large, right? So there's a lot of differences in climate as you move north to south across the state. So there's just one mixture, and the mixture does not change based on time of year that it is seeded. Now that would be an ideal scenario would be there would be mixtures that change based on season of when they're seeded, because there's certainly species that are going to do better establishing at certain times of year. And there would also probably be differences in the recommendation based on location a little bit. Now, it's difficult to manage that. We have some research ongoing right now trying to answer that question. But right now, it's just one seed mix for a type of site, just a general type of site. So there might be 3 or 4 different types of sites that are listed in the specification handbook. And then the same mixture is used regardless of the time of year.
Okay. Wow, that's super interesting. I was not anticipating to take that rabbit trail, but I'm glad that I did. And you did answer my other question, which was whether or not these grasses vary on the best seeding time. But you did mention Kentucky bluegrass, which is one of the grasses that we were hoping to discuss today. So I think what would be helpful would maybe be to go through some specific grasses that were mentioned in your paper. There were loads of them in there. And kind of highlight what are their pros and cons when included in a mix.
So Kentucky bluegrass is the most commonly used turfgrass in colder climates for any use. A lot of people have it in their lawns. And traditionally, that's been used a lot on roadsides in these cold climates as well. And if you look through most specifications for roadside mixtures, Kentucky bluegrass is very prominent. And sometimes the percentage of Kentucky bluegrass in a mix looks like it's low. It might say, 10% or 20% by weight. But the seed size of Kentucky bluegrass is very small compared to other grasses that you would find in a mix. So in practice, the number of seeds that are put out in terms of a comparison of the overall seed number in a mix is quite high. So, for instance, in Minnesota, Kentucky bluegrass has been used for decades on roadsides and recommended for decades on roadsides. And there is, like I said earlier, there is some interest, there's quite a bit of interest in putting sod down on some of these sites, because putting sod down instead of seed reduces risk of erosion during establishments, or the Minnesota Department of Transportation likes that option. Well, it was very clear to us that this probably wasn't the ideal recommendation to have so much Kentucky bluegrass in these mixtures. When we started this work in about 2010, and Dr. Josh Friel, who was a graduate student on this at the time, started this work. And one of Josh's early findings was that Kentucky bluegrass is just not a great roadside grass. And it's got a couple of problems. One is it's not most varieties anyway, there's a lot of diversity in Kentucky bluegrass. There might be a few varieties that do better than others. There will be a few varieties that do better than others on a roadside. But in general, Kentucky bluegrass is not very salt tolerant. And that's a big problem, of course, in places like Minnesota, where you are going to have roadside salt deposition on roadsides every year. There's no exceptions to that in Minnesota. Another problem is if you seed it, it germinates oftentimes very slowly, so it's hard to get established. So the establishment period is more difficult. So if you have a high percentage of Kentucky bluegrass, there's going to be more risk of getting quite a bit of weed coverage in that roadside, often annual weedy species. And that's not something you want on a roadside, because those annuals are going to die and then expose the soil the next year. One of the big advantages, however, of Kentucky bluegrass is in those sodded situations. So Kentucky bluegrass It's the most common type of sod sold in in areas like Minnesota. Maybe 95 or more percent of all sods sold in Minnesota is Kentucky bluegrass, maybe 99%. And the nice thing about Kentucky bluegrass sod is you can lay it down pretty much any time during times when it's not really cold out, and it'll be fine. It can go dormant if you lay it late in the fall and still be fine the next spring. So that's where we see a lot of advantage. That's really the primary advantage of Kentucky bluegrass on the roadside, is when it's used as sod. And our work has really identified the need to use less Kentucky bluegrass on roadsides, and it still has its place. It's still could be part of a mix, because there might be some situations where the traits of a specific cultivar of Kentucky bluegrass work well on a roadside, and there's turfgrass breeders are continually working to develop better Kentucky bluegrass varieties that are tolerant of the stresses we would see on a roadside. But there are certainly better options out there than Kentucky bluegrass. So we've really been working for a number of years now, trying to evaluate other grasses that can replace some of that Kentucky bluegrass in a good roadside seed mix.
Okay, quick question before we move on to other grasses. How is sod produced? I mean, are they just seeding it and just keeping it in a warehouse? I mean, that seems very space inefficient for as tall as grass is compared to corn or whatever that's going to grow pretty tall in the space you have.
So sod is grown on farms. They'll seed. It's like a big lawn, so they'll seed numerous acres with Kentucky bluegrass, usually a blend of cultivars, and then they'll manage it just like you would a really nice lawn, and they'll manage it in such a way that it can form harvestable sod as soon as possible, so that the grower then will go out there and cut the sod, roll it up, and ship it off to a site where it's going to be planted. So the sod stays in the field in production until it is needed by the customer, usually. Sometimes it'll be, for smaller amounts that might be cut and thrown on a pallet and brought to a greenhouse or hardware store or something like that. But for bigger projects like you would see on roadsides, it's cut fairly close to the time when it's used on a roadside. But one of the things another nice thing about Kentucky bluegrass sod is it can sit on a pallet rolled up for a decent amount of time, so that if there's scheduling issues with the roadside installation, for instance, it's not as big a deal if that Kentucky bluegrass doesn't get used right away. But then after it's harvested, the grower will, if that same field is going to be used for Kentucky bluegrass sod, go in and plant some more Kentucky bluegrass seed and do the whole thing once more.
Sure. Okay, here's a subsequent question then. So sod is, obviously it's not like mowing a lawn where you're cutting off the tops, because then it doesn't have the roots. So how are they not just shoveling down their field lower and lower each time?
That is a problem. So they do mow it just like a lawn, but that is a problem. So every time you cut sod, you're taking some soil with the sod, right? So over time, you're losing a little bit of soil, and that is a problem. And that's something that people around the country are trying to address, ways to replenish that soil and reduce some of that impact on the soil. But that is a concern that sod growers have, is that loss of soil over time. It's not a quick loss of soil; it's an over time loss of soil. But that is a problem.
Interesting. If anyone is doing that research, please reach out to us. We'd love to know. All right. So then, what are some of the other grasses that you've been looking at, and what are their pros and cons?
Another grass that is often found in these mixtures traditionally is alkali grass. And alkali grass is almost always in a mixture that's recommended for a roadside where there is salt deposition from de-icing events. And we found that, sure, it does really well under salt stress, but it doesn't do well under really very many other stresses. So that's a problem, because those other stresses are always present as well. It's always going to be dry for a while on a roadside. It's always going to be a little warmer on a roadside. So that's one that's traditionally been recommended. We do, however, see some of the newer varieties of this grass outperform some of the older types. So I think as time goes on, breeders will develop varieties that are more useful for roadsides. The group of grasses, however, that we found to be the best for roadsides in Minnesota and other similar states are the fine fescues. So these are a low input grass that we recommend for home lawns all the time here. Fine fescues is a group of grasses. It includes strong creeping red fescue, slender creeping red fescue, chewings fescue, hard fescue, and sheep fescue. And these grasses, especially strong creeping red fescue, have been recommended as parts of roadside seed mixtures in the past, and they are on the books for current seed mixtures. However, it's very clear based on our data, at least for Minnesota and similar climates, that they really should be increased in terms of the percentage based on number of seeds in a mixture, especially with new varieties being developed all the time with new abiotic stress tolerances. This is really a great way to increase the chance of success for a roadside turfgrass seed mixture. One of the issues with the older mixtures is that they were really dependent on strong creeping red fescue because the seed is more available and cheaper, which of course is a big consideration for roadside projects. We were talking about large distances of roadsides. But other species really should be considered more. So slender creeping red fescue, which has also been in recommendations before, but it is clearly the most salt tolerant of the fine fescues. That is one that we would really like to see more used to a greater degree in roadside seed mixtures. One of the problems with slender creeping red fescue is seed availability. There just is not a lot of seed production of that every year. Most of the seed for fine fescues is grown in Oregon, and there's just not a lot of slender creeping red fescue available. And then our recent work, and earlier work as well, but recent work has confirmed it, that in many parts of Minnesota, hard fescues are a really great option for these roadsides. So in general, the fine fescues need to be considered more for these mixtures. We've done work on tall fescue, which is a grass that's not commonly thought of as used in Minnesota. It's used more in areas south of here, in areas we refer to as the transition zone, Tennessee, North Carolina, Missouri, areas like that. However, it can do quite well on a roadside. Its salt tolerance is good enough, and it's got very good low input stress tolerances. So it can take high temperatures really well. It's got deep roots, so it doesn't need as much water applied. It does fine in lower fertility situations. However, it does have some problems with ice cover tolerance, and in many of these roadside situations where we're using turf grasses for aesthetic reasons, there is often risk of ice buildup. So if you think about roadsides, often you think about a ditch where there might be a slope going down from the road. And in those situations, next to the road, that's fine. There's not going to be as much ice buildup. But if you think about suburban and exurban areas where there's often a road, and then right next to the road there might be 3 or 4 feet of turf, and then a trail or sidewalk. That area in between the trail or sidewalk and the road often has a little bit of a concave appearance. So what happens is water can collect there during the winter, forming ice. So we would see this consistently, that middle of the area between the sidewalk or the trail and the road would, if it was planted as a tall fescue, would be dead in the spring. So tall fescue has its place, but it's got a major weakness there, that it does not do well under ice cover.
Okay, I have a couple questions out of that. First of all, for us non-turfgrass experts such as myself, what do these grasses look like? Can you tell them apart at a casual glance? Do you have to be a turfgrass expert? What makes a fescue a fescue? So
the grass, you probably wouldn't be able to tell some of these apart. Tall fescue and Kentucky bluegrass, for instance, for the non-expert would look pretty similar. The fine fescues are much finer in texture, as the name implies. And so those would be something you could tell apart. But if you saw them in a mixture on a roadside, you wouldn't think anything of it. You'd think, oh, that's a nice looking stand of lawn, so there wouldn't be huge differences there. Alkali grass does look a little different, but once again, when it's in a mixture, you're not gonna see a lot of differences. So Fescue is just referring to these grasses in the genus Festuca, and it's a little unfortunate that we use the term fine fescue so generally because there really are important differences between the different fine fescues, and I think that's something that, as turfgrass scientists, we have to think about and work on a little bit in terms of communication. But the tall fescue is very different in appearance than the fine fescues. Now, when mixed together, it's not a huge consideration, but it's a coarser leaf texture, broader leaf than the fine fescues. But that broader leaf looks more similar to Kentucky bluegrass than it does to the fine fescues.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Eric's paper, Review of Cool Season Turf Grasses for Salt-Affected Roadsides in Cold Climates, published in Crop Science, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thanks again also to our sponsors, GasMed Technologies and Meter Group. For GasMed Technologies, conduct greenhouse gas flux measurements in the field using the GT5000 Terra. Weighing 20.7 pounds, splash-proof IP54 rated, internal pumped battery, and vibration resistant, the GT5000 Terra is a robust and portable multi-gas analyzer for fieldwork. Visit www.gasmed.com or email sales@gasmed.com for more information. Meter specializes in robust soil moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Listen to their new podcast, We Measure the World, to hear how innovative researchers leverage environmental data to make our world a better and more sustainable place at metergroup.com/fieldlabearth. Thank you for being our sponsor. Let's get back to the show. Okay. I know you said that some of these grasses are susceptible to certain types of stresses, abiotic stresses, drought, heat, anything non-biological, or what have you. So if one type of grass mostly dies out in a mix, I mean, does that happen? And if it does, is someone called in to figure out which one it was, and you just add more, or is it just tough luck until we need to reseed everything? How does that work?
In terms of actual roadsides that are managed by public agencies, they don't worry about one grass disappearing. What they really want is good cover. So when a new roadside goes in, there'll be language in the contract that they'll come out, and the inspector will come out and say if the roadside has been officially passed inspection as a fully functioning vegetative roadside at some point. And they judge it just based on cover, and are the grass does it have good coverage? And sometimes that might be weedy species even, but hopefully not. So if one grass does die out, and it can happen, usually it might die out to a very high degree, but there'd still be a little bit left. In terms of from the DOT's perspective, they don't really care. They just want cover. They don't care that the Kentucky bluegrass died out. They don't care if it was replaced by a tall fescue or fine fescue. For our research program, we are very interested in that. We're just wrapping up a major project looking at a series of mixtures on roadsides in Minnesota, 14 different sites throughout the state, so a really big undertaking, lots of travel and logistics. But in that project, the graduate student, Don Christensen, went to the roadsides multiple times per year and actually documented the species that were present. So we've got that data now, and we have a pretty good understanding of which grasses are more persistent in different environments. But one thing we've clearly seen is that as you increase the number of species in a mixture, you get better overall function of the roadside. And, as judged by percentage cover of the turf, as judged by fewer weed species, as judged by less exposed soil. So the fact that we have, as you increase the species up to 6, that was our limit. As you increase the species up to 6, we see a pretty clear trend that that's a good thing And at one site, it could be that the Kentucky bluegrass all died or mostly died, and the tall fescue filled in. At another site, it could be the opposite, right? It doesn't really matter from a practical standpoint. It doesn't matter which one died out. It matters that you've got this mixture that the species in which the species are complementing one another.
Okay, so maybe it's kind of like let nature decide what will be successful in this specific roadside, and we'll move on from there. Well, great. I know. So that's a wonderful overview of some of the ones you were studying. You've mentioned future research a little bit. So where are we headed with that? And also, you can bulk this in. What are some of the general tips or factors for a successful mix that you found as part of this research?
In terms of future research, I think we need to continue to refine the percentages that we should be putting in mixtures for a given environment. I think this current work that we're doing, where we're looking at performance of mixtures in many different environments across the state, is important because I think it's going to be critical to understand the stresses of a specific site before designing a mixture for that site. Now, the way that the DOT in Minnesota, in most places, recommends mixtures is it needs to be fairly straightforward. They can't be recommending 80 different mixtures based on sites in Minnesota, right? But I think that consideration of there should be multiple mixtures recommended based on where in the state you are, maybe the number's 3 or 4. It looks like based on our most recent results, we're going to be recommending 3 different mixtures. I think that's going to be really important. And then more work needs to be done on the exact percentages that we would recommend. And I think it needs to be an ongoing process. So there needs to be continual or close to continual evaluation of individual cultivars of turfgrasses so that we are recommending the best, most well-adapted, best recent genetics for these sites. Because these are really tough sites. These are the most difficult sites to grow grass that a turfgrass is managed in, I would say, in most of the country. And therefore, we want to take advantage of all the good work that's being done by turfgrass breeders around the country and around the world on finding grasses that are well adapted to low input conditions. So I think there needs to be more attention paid to a process by which we update recommendations for roadside seed mixtures. The other thing that we've looked at in our program quite a bit is what's the best way to establish these? So earlier we talked about the problem of establishing roadside mixes at non-ideal times of the year. So if you are in that situation, maybe it is more economically feasible to plant a cover crop and come back and seed at a more optimum time. And that we're doing some of that work now with an horticultural economist here in our department, checking you, and trying to determine if there's, figure out that kind of cost benefit. Because public agencies, when they have to reseed a roadside, it's very expensive. So it could be that the planting of a cover crop and just waiting for an optimum time is a much better route to go. I think that work on timing of seeding and then some other things. What are some other management practices we can do to increase success? For instance, there's been work done here and elsewhere on amending roadsides to improve the soils. And sometimes that's not really feasible economically, but there might be opportunities to do a more low-cost, addition of some organic matter, for instance, on lower fertility sites. So those are probably 2 things. How do we continually provide data that can inform optimum seed mixture recommendations? And then how do we, what do we recommend to public agencies to make sure these turf grasses get established well? Because once they're established well, that gives them a much better chance for long-term success. In addition to one of the establishment practices that needs to be worked on is proper watering and irrigation during establishment. And that's a real big challenge on a roadside. These sites do not have irrigation systems in them, and usually it's a water truck that waters the roadside. So we've done work in the past looking at other ways that we could build modular systems that you could hook up to a fire hydrant, for instance. So we've developed some ways to do that. It's not something that's been used by practitioners yet, but I think that's a possibility because we've seen that whether it be in sod or seed, getting that roadside established is critical, and water is really important for successful establishment of any turf area. Even a low input turf needs inputs during establishment to get to the point where you can see the advantages of the low input genetics.
Sure. Makes sense to me. Well, those are some great tips and really cool areas for future research. Best of luck on all of those. And I've got 3 questions left for you. The first one is if people want to learn more about anything we've talked about today, where can they go?
So you can go to our turf research website at the University of Minnesota, turf.umn.edu, where we post updates on this and other projects. And then also linked there is a roadside turf site where we have housed all of our information. So roadsideturf.umn.edu. There's a number of resources there, including some educational resources for people who want to learn more about growing grass in these kinds of sites, and blog posts about with research updates, links to research reports, and so forth.
Okay. Sub question to that. You mentioned kind of establishment guides, or I don't remember the exact phrase you used, but a guide for the right seed mixes to use. How do people get a hold of that? Is that just like a contractor only secret, or like where is that available, if anywhere?
So in Minnesota, at least, when the DOT they have a specification book that has the parameter, the lists of grasses that are acceptable in a mixture. And then seed mixers in the state will respond to that by making sure they have those seed mixes available, because these contractors who put in roadsides need that seed to be available at all times of the growing season. So usually you can find it. You're not going to find it at a typical place where you would buy your grass seed for a lawn. So you're not going to find it at a big box store or a retail greenhouse. But you can find it through these local seed mixers in your area.
Interesting. Okay. So then second question for you is, if people then want to get involved in this, how can they do that? Be that as a researcher or maybe as a homeowner who's looking to help their roadside grasses, anything like that?
If you're a homeowner who has a new roadside done in front of their house and new grasses are planted, one thing you can do to make sure that it has a better chance of success is manage it correctly during that establishment period. One problem we see quite often is homeowners will have new grass planted on their boulevard, and they'll manage it just like they manage the rest of their lawn at the time. So they'll mow it whenever they mow the rest of their lawn, for instance. And that sometimes doesn't work. So sometimes, especially these fine fescues during establishment, you don't want to mow them when it's hot and dry, for instance. That can damage them a lot. So sometimes we'll see failure after the roadside has been turned over to the homeowner because they're not managing it properly. And that's one of the reasons we developed some of the educational resources we have on our website, because we want to point homeowners to the resources they need to manage their lawn differently than they typically would when they have a new roadside establishment on their frontage.
Anything for researchers who want to loop into this?
I think it's really important for departments of transportation around the country to think more about how they are going to make better recommendations for roadside vegetation, especially turfgrasses. And not all departments of transportation will fund this kind of research. Fortunately, Minnesota does, but there are several states that will, and I think researchers should seek out those opportunities. I think it's a really great opportunity to learn more about low-input grasses while providing data that can be really useful for public agencies. So there's a really clear public benefit to this work. It saves money because they shouldn't have to reseed as many roadsides with a better mixture. And it also provides better environmental benefit because you're reducing some of the problems we talked about at the beginning of the podcast.
Excellent. That is great advice. Final question for you is, what is one fun fact that listeners would not know about you if all they had was your research?
A fun fact. I'm pretty good at Boggle.
Really?
Yeah. I don't know how good I am because I don't play that many people, right? I might be just playing people that just happen to be not as good at Boggle. But I'm pretty good at Boggle. So.
All right. Well, that's a very fun fact. Well, thank you so much for being on the show today. Thank you for your patience with my cold brain fog. I'm sure that leaked in a little bit in the interview. But yeah, thank you so much for being on the show, all the hard work you're doing to keep our roads safe and beautiful and environmentally healthy. Thanks for being on.
Thanks a lot.
Thank you for listening to Field Lab Earth. You'll find links to today's resources in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on Apple Podcasts, Podchaser, Stitcher, or anywhere else you find your podcasts if you like our show. This podcast is a joint production of the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by guests are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.